All right, let's dive right in. Today, we're going to demystify the installation process for one of the most powerful tools out there for data engineering, Apache Spark. We're going to get this done step by step. But before we start typing commands, let's just take a second to remember the why. Installing Spark isn't just about getting software on a machine. It's your ticket into the whole world of big data, processing huge data sets, scaling up machine learning, and really turning raw data into some powerful insights. Now, I know what you might be thinking. Installations like this can feel a bit intimidating. A wall of text, a bunch of commands, but don't worry. We're going to break this down into a really clear, logical flow. By the end of this, you'll have a fully functional Spark setup, and you'll actually understand how all the pieces fit together. Let's do this. Okay, first things first. Just like building a house, you have to start with a solid foundation. For Spark, that foundation is Java. So in this first section, we're just going to get our Ubuntu system prepped and ready to go. So you might be asking, why Java? And that's a great question. See, Spark itself is built with a language called Scala, and Scala runs on the Java Virtual Machine, or JVM. The easiest way to think about it is this. The JVM is the power grid. Spark is the high-tech appliance. Without that power grid, Spark just can't turn on. It's an absolute must-have first step. So let's get that power grid online. It's really just 3 quick commands. First, we'll run a sudo apt update to make sure our system's package list is fresh. Then, we'll install the Java development kit itself. And finally, we'll just run a quick Java version check to make sure it's all there. And with that, our foundation is officially set. With our foundation firmly in place, it's time for the main event. Let's actually get the Spark software onto our machine. This is where we assemble the core engine. Think of this part as basically unboxing Spark. It's a simple 3-step move. We use wget to grab the official compressed file from Apache. Then we use tar to unpack that archive, kind of like unzipping a file. And finally, we use mv to just rename the long, complicated folder name to something simple and clean, like Spark. Done. Okay, so Spark is physically on our machine, but here's the thing. Our system has no idea it exists. It doesn't know where to find it. So in this section, we're going to connect all the wires and tell our operating system exactly how to talk to our new Spark engine. So how do we do that? We use something called environment variables. And the best analogy for these, honestly, is to think of them as your system's master address book. When you type a command into the terminal, the system flips through this address book to figure out where that program actually lives. Our job right now is to add a new entry for Spark. We do this by editing a special file in your home directory called .bashrc. Think of it as the main settings file for your terminal. You can see here we're adding a few lines. We create a Spark home variable pointing to where we put Spark, and we add its bin folder to our main path. We're basically writing down Spark's new address in the book. Now, this is a super important step. Just editing that file isn't enough. Your current terminal session doesn't know you made changes. That's what the source command is for. It's you telling the terminal, hey, go reread that address book right now. I just added some new stuff. It makes our changes active immediately. All right, now for a little bonus round. This next part is optional, but if you're serious about Spark, it's a highly recommended upgrade. This is how we connect Spark to a cluster manager like Hadoop Yarn, which is what unlocks its true power to run across dozens or even hundreds of machines. We just need to pop open a file called spark-defaults.conf and give it a few instructions. We tell Spark that its master is now Yarn. Then we define the resources for its main components, the driver that runs the show, and the executors that do the heavy lifting. This is literally how you tell Spark how much memory and CPU it's allowed to ask the cluster for. It's what turns it into a real distributed engine. Okay, we've laid the foundation. We've assembled the parts. We've connected the wires. Now for the best part, the moment of truth. Let's fire it up and see if this thing actually comes to life. You know that feeling, right? After any installation. You've followed all the steps, you've edited the files. You're always wondering, did I miss a semicolon somewhere? Did I make a typo? Did it actually work? Well, there's only one way to know for sure. We're going to open a terminal and type the one command that, if everything went right, our system now knows exactly what to do with Spark shell. And boom, there it is, that beautiful ASCII art logo and the Welcome to Spark message. That's the confirmation we were looking for. Seeing this means the system found Java, it found Spark, all the wires are connected, our engine is officially running. Success. An engine is great, but it's not much good if you don't take it for a drive, right? So now that we know it works, let's actually submit a couple of jobs and see what this thing can really do. For our first test drive, we're going to run a classic, the word count program. This is basically the hello world of distributed computing. It's a simple Python script that tells Spark to read its own README file, split it into words, and count up how many times each one appears. It's a perfect first test of its data processing abilities. And running it is beautifully simple. We use the command spark submit and then just the name of our Python script. This spark submit command is your universal key to the kingdom. It's how you send any application, big or small, to the Spark engine for execution. Okay, for our second run, let's level up. This time, we'll run a script that uses Spark's built-in machine learning library, MLlib. This program actually trains a logistic regression model. This shows that our setup isn't just for simple counting. It's a full-on platform ready for some serious data science. And notice this. The command to run this much more complex machine learning job, it is exactly the same, Spark submit. That consistent, simple interface is one of the things that makes Spark so incredibly powerful and easy to work with. And that's really it. We've gone from a clean slate to a running Spark engine, ready to process data and train models. We laid the groundwork, we put the pieces together, and we took it for a test drive. The system is all yours now. So the only question left is, what are you going to build first?